Hey everybody, and welcome to a video on solving absolute value equations. So, let's make it happen. Suppose that we were given the following equation. The absolute value of A equals 5. Well, that means we need to find a number whose absolute value is 5, or any number whose distance from 0 on the real number line is 5. Well, it's clear that 5 is the solution, because of course, 5 is exactly 5 units away from 0 on the number line. But negative 5 is 5 away from 0 as well, so negative 5 is a solution to this equation as well. So how do we write that? In this case, I would split up this original equation, and I'd say A could be 5, or A could be negative 5. This equation has two solutions. There are two numbers whose absolute value are 5. What about this next equation? The absolute value of W equals 8. So we're just looking for any number that's 8 away from 0 on the number line. Well, both 8 and negative 8 are 8 away from 0, so those are both going to be solutions to this equation. So we would write W equals 8 or W equals negative 8. One stylistic comment, I like to write my solutions from left to right as they appear from left to right on the number line. So A equals negative 5 or 5 because that corresponds to their position on the number line. Same thing with negative 8 and positive 8. So what about this last equation? Why don't you give this one a try? Not surprisingly, the two solutions to this equation are positive 10 and negative 10. And in general, to solve an equation of the form, the absolute value of some variable equals a number, we're going to split this equation into two separate equations. Either our variable could equal that exact number, or our variable could be equal to the negative of that number. Of course, this original number has to be non-negative because it's impossible to take the absolute value of anything and have it be negative. Now, note, right now in this general form, this x represents a variable, which just represents a number. But this is going to be the strategy for any equation of the form the absolute value of thing equals a number, where that thing can be any number, any expression. It can have all sorts of stuff going on. We're going to handle it in the exact same way. Either that thing equals the original number, or that thing will equal the negative of that number. What if we have a slightly different looking equation, like the absolute value of b plus 3 equals 5? Well, we're actually going to use the exact same strategy because we have the absolute value of something equals a number. So let's split it up in exactly the same way we did before. And let's talk about this with regard to the number line again. I don't know what b is, but we do know that b plus 3, its distance from 0 is going to have to be exactly 5. So b plus 3 is going to have to be 5, or b plus 3 is going to have to be negative 5. Now, we've got these two equations, and we know exactly how to solve them, so let's do it. So it appears that the two solutions to this equation are going to be 2 and negative 8. And if we take a look at the number line, we can see exactly how we graph our answers on a number line. Now, in a quiz or homework kind of setting, all I'd actually be looking for is this. This is enough to tell the reader exactly what the solutions are to our equation. But having all this is really nice just to see the steps that we did to come to our solution. All right, let's take a look at this next one. Now this doesn't look like anything we've seen before because it's not just the absolute value of something equals a number, we've got multiple things going on over here. Well, that's no problem at all. In general, we're going to want to isolate that absolute value so that we may split up the equation into two like we did before and proceed. So the first thing I would do here is subtract 5 to isolate this absolute value. So we end up with the absolute value of m minus 6 has to equal 8. So I don't know what m is, but I know that m minus 6, since its absolute value is 8, m minus 6 has to equal 8, or m minus 6 has to equal negative 8. Once again, we're left with two pretty simple equations that I think we know how to solve. I think we've got to add 6 to both sides of both of these equations, and we'll find our two solutions. So it appears to me that our two solutions are negative 2 and 14. And if you were asked to graph these solutions on a number line, all you'd have to do is draw in a point at negative 2 and a point at 14 on the number line. You don't have to have a 0, doesn't have to be a scale. Does it help sometimes? Absolutely, but no need to do it. You're not required at all. Hey again guys, that's it for this video. I hope you found it helpful and I hope you enjoyed.